Good morning, student. Today we start the preparation of the methods of preparation of amines. We see different methods. First we see reduction of nitro compounds. Reduction of nitro compounds. Nitro compounds can be converted into amines with the help of some reducing agent. So which reducing agents are there? Reducing agents are, the first one is by catalytic hydrogenation, catalytic reduction you can say, or hydrogenation you can say. It means hydrogen in presence of PD or PT or nickel. And second is tin plus HCl. When tin and HCl react, it produce nascent hydrogen, and that nascent hydrogen reduce the NO2 group. And the other is Fe scrap, means iron scrap with HCl. In this case also nascent hydrogen is produced, and that nascent hydrogen reduces the nitro group. Now with the help of these reducing agents, how we will convert the nitro group, we will see with the help of some example. Here we have nitrobenzene. Nitrobenzene NO2. NO2 is attached with the benzene ring, nitrobenzene, and we are taking any of the reducing agent. H2PD we are taking. H2PD, listen, when we perform the catalytic hydrogenation or catalytic reduction, in presence of medium is ethanol. Ethanolic presence is there. Ethanolic medium is there. This O2, in place of O2 you have to write H2 only. NH2. So nitro is converted into amine, and this is 1 degree amine, this is nitrobenzene, and it is converted into aniline. In place of H2PD ethanol, you can take SN plus HCl, or you can take Fe plus HCl. By using any of the reducing agent, we can convert nitrobenzene into amine. Here this is an aryl amine, aniline. Now we see some other example like simple aliphatic amines. You see how to obtain aliphatic amines. CH3NO2. This is nitromethane. This is nitromethane. So we are taking any of the reducing agent. We are taking Fe plus HCl. Then we will get CH3, and in place of O2 you have to write H2. Very simple. This is methenamine. Now one question is there, you have to make a note. It is not given in the notes, so you must write from here, that which is preferred. Industrial preparation means during the conversion of nitrobenzene or any of the nitro compound to amine, which reducing agent will be preferred in industry. So it is scrap Fe and HCl. Scrap Fe and HCl. Why? Because when Fe and HCl is reduction with Fe scrap with HCl is preferred. Why it is preferred? Because in this process FeCl2 formed gets hydrolyzed to release hydrochloric acid during the reaction. Therefore, only a small amount of HCl is required to initiate the reaction. So what is the content of this? When we use Fe scrap and HCl, so reaction is not required, but to understand you must see when Fe and HCl reacts, it produces FeCl2 and 2 nascent hydrogen. Now these hydrogens are used to reduce the nitro group. And what happens with FeCl2? FeCl2 hydrolyzed means its hydrolysis takes place. Hydrolysis takes place to form FeOH whole twice a plus HCl back. So you can see here HCl is again produced. Now this HCl is used in the process again. So a small amount of HCl is consumed during this process. But in SnCl2, when we use Sn and HCl, in that case this doesn't happen. It means more consumption of HCl was required in the process. So we prefer Fe scrap and HCl. So reasoning questions related to this will come, and you have to write only this, not the equation. Okay, thank you. Now see next question, next method. Next method is ammonolysis of ammonolysis. So you can see lysis means splitting, ammonolysis means in presence of ammonia, ammonolysis of alkyl halides. So alkyl halides, what is the general formula? Rx. X is chlorine, fluorine or iodine in this way. So alkyl halides undergo splitting, means this bond, Rx bond or CX bond you can say. So we are writing the definition. A single line definition is the process of cleavage of CX carbon and halogen bond, CX bond by NH3 molecule, means ammonia molecule, is called ammonolysis. So definition comes in the exam, means write short notes on ammonolysis. So we will write the definition and related equations. Okay. So here you see we have NH3 ammonia molecule we will see step by step. Here ammonia reacts with any alkyl halide Rx. So what happens? Here X is more electronegative, so it will withdraw the sigma bond electron towards itself, and thus the carbon attached to the halogen, means this is the alkyl group, it must contain means the carbon which is going to be attached with this halogen gets positively charged because electrons are withdrawn with the, by the halogen atom. Now this positively charged center attracts the lone pair of electron present on nitrogen. So this lone pair of electron will move toward the positively charged center present on the residual part of the alkyl halide, that is the alkyl group. Okay. Now this alkyl group will be attached to the nitrogen, and this will give R. And what happens, one more thing, an intermediate is there. Here you see Rn positive, because nitrogen has donated electron to alkyl group and form a bond, and 3 hydrogen is already present, 1, 2 and 3. Okay, and this halogen becomes halide, and since this is positively charged, so this halide is present here. A salt is formed. This is RNH3 positive X negative salt. Now again, since nitrogen is positively charged, nitrogen is a electronegative atom and it is positively charged. So here you see this is an ammonium salt. Ammonium salt. From this ammonium salt we can recover amine, that is RNH2. How? Because HX is hydrogen halide, that like HCl or HBr. So when this ammonium salt is treated with strong base like NaOH, strong base, then HX will be removed. So how it will be removed? Here you see nitrogen and hydrogen bond. Since nitrogen is positively charged, so it will take the sigma electron towards itself. Now this becomes H positive. HX will be removed now, minus HX. This HX will react with NaOH, and what we get, R, 1 hydrogen is removed, 2 hydrogen is left, and the lone pair of electron of nitrogen is restored, because initially it has lone pair of electron. Here after this breaking of this sigma bond, again nitrogen gains its lone pair of electron, and this is H2. So this is 1 degree, sorry you can't see, this is 1 degree amine. But here reaction will not stop. This 1 degree amine again react with ammonia molecule. Sorry, this 1 degree amine again reacts with this alkyl halide, and now and break the CX bond. So this ammonolysis continues. We get here 1 degree amine. After that we will get 2 degree amine. So see the reactions. See the 1 degree amine RNH2. This 1 degree amine will react with alkyl halide RX. The sigma electron move towards X, and this electron will attach this alkyl group, and we will get R and R. 2 alkyl groups are now attached, and 2 hydrogen, because in 1 degree amine 2 hydrogen is only there. And here since nitrogen donated its lone pair of electron to the alkyl group, it gets positive charge, and here X negative. Again ammonium salt is there. It is when treated with NaOH, it releases HX, H positive X negative removed, and gives RNR, one H NH bond, means one H will be retained with this unit, and lone pair came at its place. So this is 2 degree amine, and this reaction continues. Continues means now this 2 degree amine plays the role of ammonia. It reacts with again alkyl halide, same manner, R and R. One more alkyl group is attached now, and this is hydrogen. Nitrogen is positively charged, and X negative. Again ammonium salt. When it is treated with NaOH, strong base, then a removal of HX will take place, and we will get now R N R R. So this is 3 degree amine. Again still nitrogen has a lone pair of electron, so again it will react with alkyl halide, and it give so in same manner the reaction will continue. R N R R, and again one, and this here nitrogen gets positive charge, so we can write here positive and X negative. Now further, if we treat with NaOH, no removal of HX takes place because no H is there. So now the reaction will stop here, and it finally we will get, or we can write here R4 N positive X negative. This is a quaternary salt, unstable, so it is quaternary ammonium salt. Quaternary, like ammonium chloride. Ammonium chloride contains nitrogen and 4 hydrogen. Here nitrogen and 4 alkyl group is there, and again nitrogen is positively charged, and this is halide, and this is called quaternary ammonium salt. So ammonolysis, with the help of ammonolysis we can prepare amine, 1 degree amine, 2 degree and 3 degree. But the problem of this method is what? That if we apply ammonolysis to synthesize amines, then we get a mixture of amines, and this is the advantage, because we have to separate now 1 degree, 2 degree and 3 degree amines. So this is the problem of this method. Okay, now next we are moving reduction of nitriles. Next method is by reducing the nitriles, we can get the amines. Nitriles can be reduced. Here you see, this is nitrile, cyanide group is there. So we can use catalytic hydrogenation like H2 PD or PT or nickel, or we can use lithium aluminium hydride. Lithium aluminium hydride, it is a strong reducing agent and it can reduce the nitrile group. Or we can use sodium amalgam in presence of ethanol, C2H5OH. So any of the reducing agent can be used to reduce cyanide group into amine. So here you see how it breaks the pi bond. Here hydrogen is released, So one hydrogen is attached with this nitrogen, one hydrogen is attached with this hydrogen, and again this pi bond will be broken, and one hydrogen is attached to this nitrogen and one hydrogen is attached to this nitrogen. So you can see it converts into CH2 NH2. So we get 1 degree amine, very simple method that to obtain 1 degree amine from nitrile. Okay, next method is reduction of amides. By reducing amides we can get the amines, but you know that amides are the derivative of carboxylic acid and it cannot be reduced by simple reducing agent. So we require lithium aluminum hydride. Lithium aluminum hydride can reduce amides into amines. So see the reaction RCONH2. This is amide, and in place of, here you see 2 valency of oxygen, as 2 valency of carbon is satisfied with this oxygen. When we use lithium aluminum hydride, it will reduce this CO group to CH2, RCH2 NH2. So simply we can convert amides into amine. This is 1 degree amine. Okay. Next is now you see the method is Gabriel phthalimide synthesis. This is very important method. You must, and so in short notes it comes important, you must mark. So notes already see the method. Gabriel phthalimide synthesis. First you understand what is phthalimide. You know about phthalic acid. Phthalic acid you have learned in carboxylic acid. This is COOH. This is phthalic acid, PH, phthalic acid. This is the common name, or you can you know the UPAC name of this compound. Phthalic acid, when treated with ammonia, if you treat this phthalic acid with ammonia, NH, this is NH3. So you see, first you see the formation of what we obtained. Simple method, only to understand phthalimide. What is phthalimide? Here see, I am going to explain this. This is not needed to write, okay, but only to understand. CO, and this both carbons are attached with this nitrogen, and this is hydrogen. So you see, in amide 2 hydrogen is there, but in imide 1 hydrogen is there. CO, here see, this nitrogen is bonded with 1 hydrogen only and 2 carbon. So this structure is called imide. So this is phthalimide, phthalimide. So with the help of phthalimide we can synthesize 1 degree amine, and this method is very important because with the help of this method we can obtain pure 1 degree amine. Because in ammonolysis you have seen a mixture of amines are produced, but if in any synthesis or in any question it is given that how would you obtain pure 1 degree amine, name the method. So this method is Gabriel thalamide synthesis. So now we will see how this process occur. Now we are going to start the synthesis with the help of thalamide. So we have seen what is thalamide. This is thalamide. When thalamide is treated with alcoholic KOH, potassium hydroxide, and this is alcoholic, you can see you can write AlC, alcoholic KOH, then potassium salt of thalamide will form. How? This plus minus. Here you see this HOH will form H2O and K positive will come here. So the product will be potassium salt of thalamide and negative K positive. So this is potassium salt of thalamide. Now when potassium salt of thalamide reacts with alkyl halide, that is RX, then nucleophilic substitution reaction takes place. So this is SN2 mechanism will take place. Here you see this halide will take its electron, halogen will take its electron, sigma bond electron. Now this here positive center will develop, positive center, that is electrophilicity is developed on the carbon of the alkyl group. The electrophilic center is being attacked by this nucleophile. Here thalamide, nitrogen of thalamide anion is negatively charged. This will attack to the alkyl group. So here removal of halogen or halide ion and attack of this thalamide anion will take place simultaneously. So this is a nucleophilic substitution takes place through transition state. So it is SN2 mechanism because rate of reaction two molecules are present. So this is nucleophilic substitution bimolecular. Okay. Now this X negative and K positive will form KX. So minus KX you can see it will be removed, and what would be the product formed? Here the thalamide anion will attack to the alkyl group and X negative removed, so R is attached with the nitrogen and you will get an alkyl derivative of this thalamide. Now here you see CO thalamide you can write and R is attached. Here KX is removed, R is attached. Now when this alkyl derivative of thalamide undergo hydrolysis in presence of a basic hydrolysis, that is when it is treated with sodium hydroxide aqueous, so basic hydrolysis will take place that is alkaline hydrolysis will take place. So hydrolysis will take place at this carbon nitrogen bond and hydrogen, here Na you can see NaOH as this H will join with nitrogen. So 2 units of NaOH is required, 1 unit to break this bond and 1 unit to break this bond, and 2 hydrogen will attach with this nitrogen. So what we get R N with nitrogen, 1 hydrogen and 1 hydrogen is attached. So NH2 1 degree amine we obtained, and this thalamide anion is converted into sodium salt of phthalic acid. Sodium salt of phthalic acid. Here you see CO. Now this O negative. O will join with this carbon. O negative Na positive. O negative Na positive. So we will get sodium salt of phthalic acid. Sodium salt of phthalic acid. Phthalic acid. So here by this process we have obtained 1 degree amine and it is pure. It is pure. So this is very important method. This synthesis is called Gabriel Thalamide synthesis. Now here you see this step. Here nucleophilic substitution takes place, means this is the alkyl group, and here a bulky anion is going to attack to the alkyl group. But in place of alkyl, if aryl halide will be there, if aryl halide, that is ARX, that is a benzene group is there, if any benzene group is there, and in this case, if the attack of thalamide anion on this carbon faces lots of hindrance, and due to that formation of aliphatic amines only takes place, not aromatic amine. We cannot synthesize aromatic amine by Gabriel Thalamide synthesis. So this is a note you must note down. It is given in the note also, that we can synthesize only pure aliphatic 1 degree amine with the help of Gabriel Thalamide synthesis, not aromatic amine. Means aniline cannot be synthesized by using this method. It is because the large thalamide anion cannot attack to the aryl group, aryl carbon, because due to steric hindrance. Now next, Hofmann bromamide degradation reaction. It is also very important. So 3 topics are very, very important. One is ammonolysis, second is Gabriel Thalamide synthesis, and third one is Hofmann bromamide degradation reaction for synthesis. But other methods are also equally important. You practice all. So Hofmann bromamide degradation reaction is what? Degradation means that is the number of carbon will be reduced in this method. Here you see how we perform this method. When amide, because amide is there, RCONH2, when amide is treated with Br2 solution and NaOH, sodium hydroxide, then formation of amine will take place, RNH2. But this amine contains one carbon less than that of the corresponding amide. Here you see CO is removed, only NH2, RNH2, CO एक कार्बन यहाँ से घट गया corresponding amide से, ठीक है. So one carbon from the 1 degree amine contains one carbon less than that of the corresponding amide. Okay, so this is called degradation reaction, and this is a name reaction, Hofmann bromamide degradation reaction. So RNH2 plus, how we can see the formation of product, you can understand this in this method, in this way. This is for understanding, you can see how we will show this. RCONH2, this Br, we can write Br as 2Br is bonded with a single bond, and 4 NaOH. 1 A NaOH, other NaOH, NaOH, NaOH. First Na2CO3 will be removed. Na2CO3. You can see this is the removal. Na2CO3. So we can Na2CO3 is removed. So here you see the product we are writing. Na2CO3 is removed, then R will join with NH2 group. So RNH2 plus Na2CO3. How we can we write the different other products? You see, this Na and Br, NaBr. So 2 units of NaBr will also produced plus 2 NaBr. And you see H2O, and here 2 hydrogen and 1 oxygen is left again. So this is H2O. So you can see 2 water molecule is also reduced. In examination you not need to write these only for understanding. So when an amide is treated with bromine and followed by ethanolic or aqueous solution of NaOH. It may be aqueous or ethanolic. It may be aqueous or ethanolic solution of sodium hydroxide when treated with amide along with bromine, then formation of amine will take place, and here this amine contains 1 carbon less than that of the amide. So this is the method by which we can degrade the number of carbon of the amide in the newly formed amine. So this is Hofmann bromamide degradation reaction. So it is very important. Short notes comes on ammonolysis, Gabriel phthalimide synthesis, and Hofmann bromamide degradation reaction. Okay, thank you. In next video we will share the properties, physical and chemical properties of amines. You must prepare.